Hello grade 12, here Mr. G, and we are going to be making a video on Newton's law. This video is going to be either for grade 12 or grade 11. It's applicable for both grades. Okay, this was question 2 November 2017, and we want to go through the question. Alright, I want to apologize for some noises around here, the environment. There is people making houses and building the university very close to my house, and there's a lot of noise, but I cannot control that one. Okay, I'm not working in a studio or things like that. Anyway, the question said an 8 kilogram block P is being pulled by a constant force F up a rough inclined plane at an angle of 30 degrees to the horizontal at constant speed. Okay, this is the block, this is the surface, that is the angle of the surface. The surface may can incline, and that is the picture. Then 2.1.1 says state Newton's first law in words. So what this law states? This law states an object continues in a state of rest, that is the first important thing, or moving at constant velocity. Velocity must be constant unless a resultant net force acts on it. And there is 2 marks for staying the definition. Okay, let's go to question 2.1.2. I hope this is clear. It's just staying the law. Question 2.1.2 said draw a label free body diagram for P. So what forces are acting on P? First of all, we have the applied force up the incline. I'm going to write applied force. Now perpendicular to that one, make sure you do this one perhaps with a ruler. You have the normal force. Right? And pointing straight down, you will have the gravitational force or weight of the block. Pointing straight down here is the weight of the block. Right in the opposite direction of motion, the block is moving up, you will have the frictional force. These are the 4 forces acting on that specific block P. You will get 1 mark per force. Remember something in the question of the free body diagram. If the question is 4 marks, as I said here, that means that you must have 4 forces. And if you get any extra or additional force, you lose 1 mark. So for example here, you cannot draw the components of the weight because you will lose a mark. So this is question 2.1.2. Let's go to next question. Now in this question they say the kinetic frictional force between the block and the surface of the inclined plane is 20.37. Calculate the magnitude of the force. So for this question we are going first of all to do the free body diagram, but we are going to do a different one. This one is going to be with all the components and the axis. So we have here the free body diagram with axis. I draw the axis and we have the forces. Now note that the weight of the on the object is in none of the axes, so we have to find out the component of the weight. Here is weight in the y-axis, and that is equal to weight multiplied by cosine of theta. Remember this is theta here, and then you determine the component in the x-axis. This one here will be weight in the x-axis, and the weight in the x-axis is equal to weight multiplied by sine theta is opposite to the angle. So this is important. And now let's write the data for this question. Data we have. What do we know? We know that the mass of the object is 8 kilograms. We know that the object is moving at constant velocity. That is very important. We know that the frictional force is being given to us is 20.37, and we know that the applied force is what we are looking for. Okay, so that is very important. Now we have this one. Let's determine what law can help us to solve this problem. Okay, so the object is moving at constant velocity, therefore we have to apply Newton's first law. Newton's first law said that the net force is equal to 0 because the object is moving at v constant. Okay, remember you state the law in the first question. So now we're going to see what forces are acting on the object, and we're working in the x-axis because the object is moving in the x-axis. So what forces are acting there on the object? We have the applied force, which is positive, taking the direction in which the object moves as positive, minus the frictional force, minus the horizontal component of the component of the weight in the x-axis, right? And all that is equal to 0. If we carry on calculating the component of the of the weight in the x-axis, this one here, that one, we have the formula there. So the component of weight in the x-axis is equal to the component, or to the weight, multiplied by sine of 30 degree. Okay, and this one can further on go to mg. Remember, weight is equal to the product of mass times acceleration due to gravity, multiplied by sine of 30 degree. Okay, and then you may substitute all the formula there. So you have now the applied force minus the frictional force minus mg sine 30 degree equal to 0. And then you can substitute all the data you have. Applied force minus frictional force, which is 20,37 minus 8, that multiplies 9,8 sine 30 degree is equal to 0. And this, then the final answer for the applied force is going to be 59,57 in Newton. That is the final answer for this question. If you mark your work, there will be 1 mark for the starting point, which could be either that one here or here. You will get 1 mark for the 0 in this question, 1 mark for the 20,37, 1 mark for this substitution, and 1 mark for the final answer, and that gives you a total of 5 marks. I hope you understand that work. It's not that difficult. Okay, let's go to the next question. Now, next question say the force is now removed and the block accelerates. Okay, the block is going to accelerate down the plane. The kinetic frictional force remains the same. Calculate the magnitude of the acceleration of the block. So now here we are going to first of all redraw the body here. Okay, we have the object which is sliding down. The frictional force then is the same but pointing in the opposite direction because the object is now moving down. Okay, and we have an acceleration. So what law are we going to use here? Now here we are going to use Newton's second law. Now let's first of all do the free body diagram. Okay, there is the free body diagram with all the forces acting. Now in this case we don't have an applied force. It's very similar to the other one, but the object is moving down, and therefore we're going to take down as positive. Okay, so down the incline is positive. The frictional force is the same magnitude, but it turns to the back. Okay, so we're going to use Newton, or apply Newton's second law to this specific situation in order to calculate the acceleration. So Newton's second law, we say that the net force is equal to ma. What forces are acting here? Remember, we're still working in the x-axis. They are the forces. So we have that weight in the x-axis minus frictional force is equal to ma. Why weight in this case is positive? Because the object is moving down and we are taking down as positive. So now weight in the x-axis is equal to weight multiplied by sine of 30 degree minus minus the frictional force is equal to ma. And if you carry on, this one is mg sine 30 degree minus frictional force is equal to ma. If you do all the substitution, you get now 8 multiplied by 9,8 sine 30 degree minus the frictional force, which is going to be 20,37 equal to the mass is 8. So the final answer for the acceleration is going to be equal to 2,35 meters per second square. If you mark in your work any of these formulas there, will give you 1 mark, any of them. The other mark is for the whole substitution on the left hand side, 1 for the right hand side, and the final mark, and this gives you 4 marks. Okay, so this is the calculation of the acceleration of the object when it's sliding down. Let's look at the next question. Now, this question is not going to be in this special control test now, the first control test, but it may be for later examination. Okay, let's say a 200 kilogram rock lies on the surface of a planet. The acceleration due to gravity on the surface of the planet is 6 meters per second square. State Newton's law of universal gravitation in words. So this law states that each object in the universe will attract every other object with a force that is directly proportional to the product of the mass. So the force here is directly proportional to the product of the masses, and then you get 1 mark for saying that, and that force is inversely proportional to the square of the distance between their centers, and then is the second mark for this question. This question carry 2 marks. Okay, so next question. Next question say calculate the mass of the planet if its radius is 700 kilometers. So let's write down the data. Let's see what we have. First of all, we have the radius of the planet, and that is equal to 700 kilometers. Remember, you cannot work in kilometers, so this is 700 multiplied by 1000, converting to meters. Okay, we have that the acceleration due to gravity in that specific planet is 6 meters per second square, and we have that the constant capital G, constant of gravitation, is given to you is going to be 6,67 times 10 to the minus 11 Newton meter square per kilogram square. That is the unit for that capital G. And then we are looking for the mass of the planet. We're looking for the mass of the planet. So what formula can we use? Well, acceleration due to gravity is equal to capital G multiplied by the mass of the planet divided by the radius to the power 2. If we do the substitution here, we have that is equal to 6, or 6 is going to be equal to 6, let me fix that one, 6,67 times 10 to the minus 11 multiplied by capital M divided by the radius, which is 700 times 1000 to the power 2. The mass of the planet at the end is going to be 4,41 times 10 to the 22 kilograms. This I went a little bit fast because it's not going to be asked in this specific control test, but it may be used later on. So there's 1 question for that formula, 1 for the substitution of the 6, 1 for the substitution of the radius converted already, and 1 for the final answer. There is the 4 mark for this question. So this question is now done. I hope it helped. You can show with your thumb up if it helped. Thank you very much for watching. Good luck, and once more I am going to apologize about all the noise and this the things you can hear around, but there's people constructing near to my house. Thank you very much. Good luck, and I'll see you next time.